Hi everyone. So let's start our training module for Cisco Cybervision consisting of basics and hands-on training. This course will have multiple parts and we will be starting with first part, that is introduction to IoT and OT technologies. Let's start with detail of IoT and industrial IoT. IoT has been generic name for everything, but that's not true. Each of the term has different meaning. IoT stands for Internet of Things, is a technology that facilitates the seamless connection of diverse devices, enabling them to communicate and exchange data at relatively low cost. On other hand, industrial IoT is tailored for industrial applications like industrial machineries, equipment, processes, enhanced productivity, efficiency, safety. OT technologies are devices that controls industrial world. Hardware, it can consist of hardware, software technologies, which are used to monitor, control, and automate physical processes in industries. Industrial control system is basically used to orchestrate industrial processes through OT and IoT devices. It's used to monitor and control industrial processes, infrastructure, machinery, SCADA, DCS, etc. If we look at the definition of IoT and industrial IoT, so IoT basically, as per Wikipedia 2023, it is consisting of IoT describes as physical objects or groups of such objects which with sensors, processing abilities, software, and other technologies that connect and exchange data with each other devices and system over the internet or other communication mode. So basically, we are trying to connect the unconnected. It can consist of sensors, controller, actuator from OT side. Okay. If we look at components of IoT, so IoT component can be consisting of, if we break up, it will be the first layer will be things or devices. Second can be gateway. Third is cloud. Then analytics, and last is the user layer. So let's start with welcome to the world of IoT, where devices and sensors are the foundation of the connectivity. These smart sensors tirelessly collect data from environment and transmit it to the next layer of IoT architecture. It could be like smart meters to a multitude of sensors, range of devices that gather data in vast. They communicate with servers and create a network of information flow. This information flow can be shared to gateway using various modes like Wi-Fi, Zigbee, Bluetooth, LoRaWAN, and so on. Enter the IoT gateway, a crucial component that manages bidirectional data traffic between different network and protocols. It acts as a translator, ensuring interop between devices and sensors. Additionally, gateway can be configured to pre-process and collect data, which is also called as fog computing. For many use cases, cloud computing extends to the edge of the network, known as edge computing or fog computing. This solution reduces the amount of data that needs to be sent to the cloud and optimizing the efficiency. The cloud plays a vital role in managing the massive amount of data generated by devices. So application and the user, it offers the tools to collect data, processes, manage, store vast amount of data in real time. Industry services can remotely access the data and make this crucial decision when needed. Analytics. Analytics is a process to transform analog data from billion of smart devices and sensors into a valuable insight, because early in the cloud we are receiving a raw data. It requires to be analyzed. These insights are interpreted using detailed analysis, make smart analytics. There could be component of artificial intelligence coming into the picture. So this is important and essential component to manage and improve the entire IoT system. Finally, The last component will we can say is a user interface, the visible tangible part of IoT system accessible to the users. The designer plays a crucial role in creating well designed user interfaces that minimizes the effort and encourages seamless interaction. The elements of IoT, we can say that it is three worlds which could be termed as or coined as IoT. In world of technology, not a single device is created are equal. Consumer and IT devices may excel in control and safe environment, but when it comes to harsh environment, highly demanding environment like corrosive, high temperature, they simply cannot withstand the challenges. Consumer devices, IT products are designed for everyday use in regular office, home environment where conditions are relatively controlled and safe. However, when we come down to industrial industrial use cases, the organization and factories require devices that are built with industrial strength, capable of withstanding and demanding condition they face. This is where the OT devices come into the play. These devices are specifically designed to meet industrial requirement and have become focus of attention for organization, factories, industries involved in manufacturing, energy management, predictive maintenance, so on. The consumer Internet of Things. So these are basically IoT devices, and their applications are quickly integrating in our daily routine. For example, personal IoT devices like smartwatch, hearable devices, smart glasses are can be termed as personal IoT. Then the next segment could be smart home IoT, light fixtures, family entertainment, kitchen gadget. There are other keys also like Internet of Medical Things IOMT and Internet of Vehicle Things. Poorly secured product has been threatened consumer privacy, and some of the devices are exploited by the attackers. OT, defining OT operations. So OT is basically hardware and software that detects the causes a change through direct monitoring or control of it could be used to control of industrial equipment, assets, and processes and events. So this is as per Gartner Wikipedia. So this is basically what we are trying to manage assets and processes. So if we look at evolution of IoT, Internet of IoT. So earlier in Industry 1.0 was around 1784, the invention of steam engine kicked in, started the Industry 1.0. However, the manufacturing was purely labor oriented and tiresome. The next came is IoT 2.0. In 2.0, the first assembly line production was introduced. Henry Ford, the father of mass production, the assembly lines were introduced and processes in car manufacturing and plant by Ford. Industrial 3.0 around 1969, it involved advancement of electronics, industrial robotics. This simplified, automate, and increased the production. However, the operation remained isolated from the entire enterprise network. So this was still running in the silos. Then the next era 4.0 started. This version started to connect with enterprise through interconnecting industrial assets, and through internet was fulfilled an introduction of IoT Industry 4.0. Smart devices communicate with each other, create a valuable insight. IoT brought advantages to the asset optimization, production, integration, monitoring. So, lot of intelligence and decision making was now introduced, and this all the data what our OT was been doing was been collected and processed. Okay, let's move on to the next segment. Industrial OT models and verticals. So, on high level, IoT or industrial IoT can influence various industries. It could be manufacturing, it could be roadways, it could be ports and terminal, rails, utilities, smart cities. So each industry has a different set of use cases for IoT for processes optimization or cost saving or safety. If we look at IoT and manufacturing, those changes have become a rapid pace, An industry that was once slow to evolve is now digitizing at lightning speed. IoT manufacturing market is likely to hold a revenue of approximately 265 billion in 2023, while it's anticipated to cross value of around 950 billion by 2023. So this is huge fold or a multifold increment in the value. It is basically used for increasing the efficiency. The biggest benefit of industrial IoT, that gives the manufacturers the ability to automate and therefore optimize their operational efficiencies. Robotics, automated machineries can now work much more efficiently and accurately. This helps to boost productivity, help the manufacturer to streamline their function. The next could be smart manufacturing, process optimization. So this could be the second option. This is like real-time data sharing analysis are been facilitating the process optimization, efficiency improvement. It could be also used for equipment monitoring, predictive maintenance. Sensors are embedded in and collecting the data on parameters like temperature, vibrations, pressure, energy consumption. So this data are transmitted to centralized system, which where the analytics algorithm can analyze it to detect any anomaly, predict the failures, and optimize the maintenance schedule. By implementing the predictive maintenance strategies, manufacturer can reduce unplanned downtime, extended lifespan of the equipment, and avoid costly breakdowns. Second could be other options could be supply chain management, quality of control, safety, worker safety, data analytics, shorter time to market, error reduction, dual team digital twins, and reduced cost. Similarly, if we go to industrial IoT in transport, it could be used for like fleet management, asset tracking, traffic management, smart parking, condition monitoring and maintenance, supply chain optimization, passenger experience. So it has a lot of use cases in the transport industry. If we switch down to IoT in mining, again the primary is like asset monitoring and maintenance, remote operations and automation, safety, risk management. In IoT, in oil and gas segment, it could be used for remote monitoring again of assets, predictive maintenance, safety and security. So use cases might be similar for each of the industry, but their end devices or end goals are a bit different. So it could be used for many more. For like oil and gas also needs to environmental monitoring and compliance, operational efficiency. Okay. Internet of everything. The reality is that we are all connected. The chances are, we as we are reading this course, you might be connected via email, SMS, social media. In this section, we'll learn about how information adopts the way we behave, how businesses use data and essential to collaborate. So this could be divided into pillars like people, which we are. The next could be think pillar, which comprises of various traditional computers, various devices such as desktop, laptop, etc. And then next is the data. Data is the key element for all computing system. For early computing, the current system, the fourth pillar is the processes. Processes play an important role in how other pillars, things, data, and people work with each other and deliver value out of Internet of Everything. Let's move down to IoT technologies. There are a set of motivation and challenges with industrial IoT adoption. The primary use cases could be like operational efficiencies, data driven insight, enhanced safety, cost reduction, quality, and the objective could be, outcome could be manufacture more, faster machines, and lesser downtime. There are various standardization bodies like IEEE, IETF, ETSI, so which are playing a very important role for IoT as well as on the IT segment also. If we look at various IoT protocol, the like data protocols could be MQTT, COAP, AQMP, XMPP. This could be using the communication protocol like Wi-Fi, LoRaWAN, which many of we are already using like Wi-Fi, LoRaWAN, and a couple of this in our uh, IT side also. It could be then the 6LoWPAN, IPv4, RPL. For these are the various protocols that could be used to configure, and these are basically the backbone for the IoT system. If we look at the protocol stack versus the our web stack, so it the layers could be similar on, but each of the layer the functionality might will be differing to some extent. The protocols that are used or data format that are used in IoT stack will be somewhat different. As I said, COAP, MQTT could be used for communication at application layer, whereas in our web layer, HTTP, DHCP, etc., plays a pivotal role. Transport layer could be UDP, DTLS, and here it could be TCP, UDP. So same goes with the internet. If we look at the application layer, HTTP is still the used on almost all the segments in terms of data format, or in terms of IoT stack. MQTT is used. It is a very lightweight messaging protocol based on publisher subscriber model. XMPP, extensible message presence protocol for real time communication between like chat, voice messaging. AMQP is basically an open application layer protocol for business messaging. This supports again supports a publisher subscriber model. If we look each of the protocol, how protocols are selected, each has a different communication pattern, a different set of devices, and different QoS requirement. So based on our the actual field requirement, we select the actual the ground protocol that we are going to use. And it could be mix and match also in terms of the application layer and the transport layer. If we move down to transport layer and internet layer, so it is also still the similar layer. Here we could see the additional protocol like RPL, but mostly still IPv4, IPv6 routing are being used. Additionally, we can 6LoWPAN being used. On the physical layer, it is still the similar way how network link is linked to the web socket layer. So that's all from my side for this part. We'll again meet in next part where we'll be we'll get introduction on OT technologies. Thank you.